Hello, and hopefully you have already done the warm-up for 8.4. Our swab app today is a simplify rational expression. So from the warm-up, you can check your answers with the ones that you have here, and make sure that you're okay with factoring. Today, in order to simplify these, beautiful people, the main thing we have to do is to factor in terms of everything we're going to do for 8.4, 8.5, just moving forward. Factoring is super important. So that's what we're going to do. Step one. In order for us to simplify this first example, first thing I'm going to do is factor, but we already have factored this. It's actually the factoring problem from number 1. So I'm just going to write that as x minus 6 times x plus 1. And if you're concerned about factoring, or if you need a review of how to factor using a factor box, please make sure that you come see me. The denominator factors to x plus 1. It's a special pattern, times x minus 1. That's the a squared minus b squared equals a plus b, a minus b. One to remember. So then we're going to do like you did with any other fraction when you had to reduce it. Looking at what they have in common is x plus 1 and x plus 1, so that cancels out. We can cancel it because it's the whole unit is the same. And so what's left is x minus 6 over x minus 1. Notice here, I'm not canceling these x's. This is x minus 6. This is an x times 6, so there's no canceling for that one. And then you're done. You've seen problems actually like number 2 before, so this is kind of just a little bit of a repeat. One thing that I don't do, it's mostly because it gets confusing for people typically, is I don't always cancel variables, but I will cross cancel or cancel numbers as much as I can. So I'm looking at this problem and I'm seeing a 6 and an 18. So 6 goes into 6 one time, 6 goes into 18 3 times. I'm cross canceling, I'm reducing. And then I'm looking this way as well, and I see I have 2 and 10. The number that goes into 2 and 10 is 2, so 2 goes into 2 one time, 2 goes into 10 5 times. One thing I will do, just because it's really direct, I do have x squared and x squared. So if you don't mind, I'm going to cancel those and cancel those, although I don't normally do variables. And then I'm going to multiply straight across. So 1 times 5, sorry about that, 1 times 5 is 5. And then this x squared was gone. This x cubed is still there, so I'm going to write x cubed. I'm going in alphabetical order. And then y cubed times y to the 4th. They have the same base, so I'm going to add the exponents. 3 plus 4 is y to the 7th power. In your denominator, you have 1 times 3, which is 3. There aren't any x's, but y squared times y squared, same base again. So I'm going to add the exponents and get y to the 4th. 2 plus 2, 4. One more thing it looks like I can do here. Nothing I could reduce with the 5 or the x cubed, but I do have y, the 3 either. I have y to the 7th over y to the 4th. So when you are dividing, as opposed to when you're multiplying, we add the exponents, but when you're dividing, you subtract them. So 7 minus 4, which would be y cubed. And that's that. So that's how we simplify, just simplify them. What we're going to do next is to multiply and then divide in a moment as well. So for multiplying, same thing. First step, beautiful people, factor. So I'm looking at this part right here, that 3x minus 27x cubed, and I have a little bit of a problem with that. My issue is that it's not in standard form, and I would really, really like for it to be. So in standard form, this would be negative 27x cubed plus 3x. I'm just rewriting it so that the higher exponent is first. Okay, now I'll try to factor. Now, this lesson is about simplifying rational expressions. This is not a review on factoring. If you would like that review on factoring, I'm more than happy to work with you offline on that. But for now, not the lesson we're doing. So, looking at this negative 27x cubed plus 3x, they both have negative 3x in common. Then I can factor that negative 3x out, and what's left? Well, negative 27 divided by negative 3 is 9. If I had x cubed and I took off an x, and now have x squared, and then what times negative 3x gives me a positive 3x? Negative 1. Cool. Now this one in the denominator here, this 3x minus 2, if you look up, minus 1, at number 4 on your warm-up, we have factored that already, and that is 3x plus 1 times x minus 1. That's me factoring this. That's right here. Now, 3x minus 4 plus 1, we did, or just me and you just copied my answers. But that factors, if you look at number 3, to 3x minus 1 times x minus 1. The denominator right here, I can't do anything with it. It's just 3x. Now, this is a special pattern. It follows the same pattern that we just talked about up here and that we use for number 2. It's a difference of 2 squares. Difference of 2 squares. So, this negative 3x, nothing I can do with that. But, beautiful people, I can factor this a little bit more. So this factors to 3x plus 1 times 3x minus 1. Grand. So this is now this. Let's cross cancel as much as we can. So one thing I'm seeing is this is 3x plus 1, 3x plus 1. And x minus 1, x minus 1. Can't cancel these out because they're both on top. But I'm looking at the denominator in this numerator here. 3x and 3x. But I do still have that negative sign right there. So what's left of all of this? Well, I don't have anything in the denominator, so that's nice. But I have that negative sign we had there. That went away, that went away. I still have 3x minus 1. And I have another 3x minus 1. So instead of rewriting them, I'm going to write it as squared. I would want you to do that. So negative times 3x minus 1 squared. And that is your final answer. Voila, next page. What's the difference between multiplying and dividing fractions? Not much, except we have to multiply by the reciprocal. So remember, the first fraction stays the same, 3 over 4x minus 8. And now we change this division to multiplication, and we're going to multiply by the reciprocal. So that's x squared plus 3x, and up top, x squared plus x minus 6. Now, I'm realizing that I told you before that the first thing you should do is factor, and I forgot to factor because I was so excited about dividing fractions. So I'm going to have 3 on top. This is me. I'm kind of ignoring this for just 1 minute. Just a minute. Oh, my nails look dope. And I'm going to focus right here. 4x minus 8. What goes into 4x and 8? 4. What's left? If I took off, again, I'm kind of ignoring this for a moment. If I took off 4, I still have x minus 2 times. Now, I'm going to look at this right here. And I believe you have already factored this. It was in the numerator. It was in the warm-up, maybe. If not, oh, no, we didn't. This is different. This factors, and you can use a box if you don't believe me, to x plus 3 times x minus 2. And then your denominator, what do these two have in common? An x. And what's left? X plus 3. Now that everything is factored, I'm now going to cancel anything that can be canceled. So x minus 2, and I see an x plus 3, and that's it. So what's left? I still have a 3 up top, and I also have 4 and an x, so 4x in the denominator. All of that simplified just to that. And right now, what I am realizing is that I did not do everything that they asked me to do. They asked me also to state any restricted values. So what would be the restricted values for this one? Well, basically, we have a problem with fractions when the denominator equals 0. So for this problem right here, what we do is we say 4x cannot equal 0. Can't, because the denominators can't equal 0. So you divide by 4, divide by 4. So x cannot equal 0. That's a restricted value. Okay. I'm going to trust you to be able to do that one on your own. Now, this is a wonderful big Bertha of a problem. So my first step is going to be to put this over 1 and then to factor. So this one, I'm fine with this. X over x minus 2. Then I see times, so times 2x plus 3, and I'll put that over 1. And then I see divided, so I'm going to change that to times. Well, the reciprocal. This is x minus 2. This one, guys, I like it because there's only 2 terms right here. And what do I like about it specifically? I like it because it's a difference of 2 squares. This is a difference of 2 squares. So this should factor to 2 squares, 2 sets of parentheses. What squared gives me 4x squared? 2x. What squared gives me 9? 3. One has to be plus and one has to be minus. So that numerator up there factored to that. That's low-key smeared. Okay, now cancel everything in the whole wide world that you can cancel. So what does that mean? Well, x minus 2, you're now gone. You have been eliminated. You're the weakest link. 2x plus 3 is also gone. Anything else? No, I can't cancel this x and this x because this is 2 times x minus 3. If this was just 2x, I'd be good to go and I can cancel the heck out of it. But it's not, so I can't and I won't. So, leftovers. I have an x up top still, and then in the denominator I have 2x minus 3. And what's excluded? Well, I keep forgetting. So 2x minus 3 cannot equal 0. So 2x, if you add 3 and add 3, cannot equal 3 divided by 2 divided by 2. X cannot equal 3 halves. If so, this would be undefined. That's how you do your restricted values. All right, thank you so much, and have a wonderful day.